Dear students, in the last class we discussed about surface tension, that too mathematical expression. We know that surface tension is nothing but force per unit length. Surface tension T is equal to F by L. At the same time, we discuss how to find out the minimum force to lift the bodies. I think we discussed for the rod, we discussed ring and disc and square lamina we discussed, right? So now in this session we will discuss about surface energy. See, try to understand surface energy. So I can say one thing, the surface energy is similar to energy stored in the spring. Energy stored in the spring. We know, for example, in work energy chapter, maybe we know how to deal with the spring, right? So initially spring will be there. It is in the normal state, and when it is pulled, when it is pulled, then automatically spring force will be developed. Spring force is nothing but the restoring force. So restoring force will be developed. So restoring force want to make the spring in the normal situation. Clear? So in order to bring the spring into the normal position, spring has to do some work done. That work done is stored in the form of potential energy. That potential energy we know U is equal to half kx square. Potential energy of a spring is half kx square. So similar to the same concept here, just we will try to understand one rectangular frame. The frame is like this, for example. Rods are there. Two rods are there. The frame is like this. And on the frame one mobile rod is there, lightweighted rod is there, mobile lightweighted rod, right? Then in my hand I am having the frame. I dipped in the soap solution and I lifted up. When I dipped in the soap solution and I lifted up, so here a thin film will be formed. So I will draw here. So here a thin film will be formed here. It is a thin film. Correct? Now try to understand here. In this situation, for example, I want to displace this rod through a distance dx. For example, here I want to displace this rod through a distance. For example, delta x I want to displace. So when I want to displace the rod, so here due to this surface layer, some tension will be generated. So I want to pull in this direction, and tension is pulling in this direction. So in order to pull this rod through a distance dx, I have to apply the minimum force which is equal and opposite to the force developed by this tension. Clear? I hope you understood, right? In order to displace the rod, because when I am going to displace the rod, so tensional force is acting in this direction, it will again pull the body. So in order to displace this rod, so the minimum force, how much I have to apply? The minimum force should be equal to the force developed by this tension. So for this, in this situation, just try to understand. Let dW be the amount of work done, to displace the frame, through a distance dx, right? See here, in order to displace a distance dx, how much work is there? dw. So we will write the formula. So dw is equal to work done is nothing but force into displacement. dw is equal to force into displacement. Clear? Now this force should be equal and opposite to the tension of force. Due to tension, how much force is developed, that force you have to write. So we know that tension is nothing but force upon length. So from that I will write F is equal to T into L. F is equal to T into L. So now one thing we have to understand, when I am displacing here to a distance dx, so tension force will act. So I already told you in the last classes, tension force will act on the free surface. Right? That means the surface which is exposed to air. It is a thin film. For the thin film, how many free surfaces are there? Two free surfaces will be there. So when two free surfaces are there, so here force is nothing but tension into length. That length is nothing but, which length it is? This side one length and that side one length. So it will be 2L. So I will write F is equal to T into 2L. I hope you understood, right? Clear? Now see here. Therefore from here I will write dw is equal to force into dx. What is dx? Force is nothing but 2TL. I will write 2TL into dx. Right? Now again I am modifying. dw is equal to T into 2L dx. What is L dx? L is nothing but the length. And dx is this breadth. So length into breadth is nothing but area. So this side increase in area and back side increase in area. So total area is how much? 2 times. So here 2 into L dx is nothing but delta A, or dw can be written as T into dA. So this is the minimum amount of work done to displace the frame through a distance dx. So when we are displacing like the spring, when spring is displaced by distance, the energy stored is nothing but the potential energy. So here also when we are displacing due to the change in its position, so the thin film gains some potential energy. So this work done is stored in the form of potential energy. I will write du is equal to T into dA. Very important formula. du is equal to T into dA. From that, if you want, T is equal to du by dA. What is T? T is equal to du by dA. So in two ways we can able to find the tension. So tension is nothing but force upon length, or we can write tension is nothing but du by dA. What is du? The work done or change in energy. And what is dA? dA is nothing but increase in the surface area. We have to be very careful. If it is a thin film, two surfaces are there. If it is a drop, for the drop, only one free surface will be there. Am I clear? I hope you are understanding, right? So please make a note. See here, in this question, calculate the work done against surface tension in blowing a soap bubble from radius 10 cm to 20 cm if the surface tension of the soap solution is 25 into 10 power minus 3. So initially soap bubble is there. Soap bubble having radius how much? 10 cm, and we are blowing from 10 cm to 20 cm. In order to blow, we have to calculate work done against surface tension. That means how much work we are going to do. Clear? So we know only one formula. So the formula delta W is equal to delta W is nothing but T into delta A. This delta W is also known as delta U. Energy is nothing but the work done. That's why I wrote here delta W is equal to T into delta A. T is given. T is equal to T is equal to 25 into 10 power minus 3 Newton per meter is given. And I want to calculate delta A. Delta A is nothing but increase in its area. Increase in its area. So while we are calculating delta A, it is very important to understand whether it is a soap bubble or a liquid drop. It is soap bubble or liquid drop. In the question what is given? He is given that it is a soap bubble. So for the soap bubble, how many free surfaces are there? For the soap bubble, how many free surfaces are there? 2 free surfaces are there. So first what we have to calculate? We have to calculate delta A and multiply with 2. Multiply with 2. So now we will calculate delta A. Delta A is nothing but final area minus initial area. So here delta is nothing but 4 pi R final square minus 4 pi R initial square. So here 4 pi will take common. So what is R final? R final is given 20. So 20 into 10 power minus 2 whole square minus 10 centimeters. 10 into 10 power minus 2 whole square. Right? Clear? Now we can calculate here delta A. So delta A can be written as 4 pi and here I will write 10 power minus 2, 10 power minus 1. So 4 into 10 power minus 1, 10 power minus 1. Here 2 square 4, 10 power minus 1, minus 2 will be there. Minus, here it is 10 power minus 1 and again 10 power minus 2. So here it is delta A is equal to 4 pi into 10 power minus 2 I will take common. So 4 minus 1. So 4 minus 1 is nothing but 3. 3 4s are 12. So delta A can be written as 12 pi into 10 power minus 2 meters square. This is delta A. This is delta A. But it is soap solution. So delta A becomes twice. So here I will write a total delta A. Delta A total can be written as 2 into 12 pi into 10 power minus 2. So it is 2 into 12, 24 pi into 10 power minus 2 meters square we got. So now we can calculate work done. So work done can be written as T into delta A total I will write. Delta A total. So here W is equal to T is nothing but 25 into 10 power minus 3 into 24 into pi into 10 power minus 2. So if you calculate, we will get the amount of work done, right? So if you calculate, you will get 6 pi into 10 power minus 3 joules will be the final answer. Am I clear? I hope you understood, right? So we calculated surface energy. So the amount of work done against the surface tension. How much work we have to do in order to increase or in order to compress. So how much work we have to do against the surface tension, that work done is nothing but surface energy. So generally surface energy is denoted by delta U. Delta U is equal to T into delta A. So delta A is nothing but increase or change in the area. Change in the area. While we are writing the change in area, so we have to be very careful. If it is a one surface, if it is one free surface, you will write delta A. If it is two free surface, like soap bubble or thin film is having two surfaces, two free surfaces. Soap bubble is having two free surfaces. So you have to multiply with 2. No liquid drops is given. For the liquid drop, no need to multiply, only single surface area is there. Right? I hope you understood, right? Thank you.